As you can see from the periodic table, most elements are metals, and we find them towards the bottom left of the table. One of the key features of metals is that they form positive ions when they react, like a calcium 2+ ion. Whereas non-metals either don't form ions, like carbon, or they form negative ions, like chloride 1-. To understand why this is, we need to consider the electron arrangements of the atoms. And remember from previous videos that all atoms want to have a full outer shell of electrons in order to be stable. If an element is found on the left of the periodic table, then it won't have many electrons in its outermost shell. For example, calcium in group 2 has 2 electrons in its outer shell. This makes it easy to lose these outer electrons and form a positive ion. On the other hand, something like chlorine, with 7 electrons in its outer shell, would have to lose all 7 of them in order to become a positive ion, which would require tons of energy, and so doesn't happen. Another feature of metals is that they tend to become more reactive towards the bottom of the table. This is because elements far down the table have lots of shells. For example, lead, which is Pb here on the table, has 6 shells, so its outermost shell is really far from the nucleus. Now remember that in any atom, it's the positive nucleus that holds these negative electrons in place. So if the electrons are really far away, like those in the 6th shell, then the nucleus can't hold on to them so strongly. So the atom will lose them more easily and form a positive ion. This feature is what makes those metals further down the group more reactive. They're just more likely to lose their electrons during a reaction. So now that we know how metals and non-metals differ in terms of their electron arrangements, we need to consider how this affects their physical properties. First, all metals have metallic bonding, which is a special type of bond that only metals have. We take a closer look at it in another video, but for now, just remember that metallic bonds are very strong, and they're responsible for metals' physical properties. As well as being strong, metals are also malleable, which means that they can be bent or hammered into shape without snapping. They're also great conductors of heat and electricity, which is why we use them in electric wires. And nearly all of them have high melting and boiling points. In fact, some of them still won't have melted at 2000 degrees. Other properties include being shiny and being sonorous, which means they create a ringing sound when you hit them. Non-metals, on the other hand, tend to be dull in colour, brittle, which means they easily break, like the carbon in your pencil, and generally have low melting and boiling points, with many of them being gaseous at room temperature. They're also poor conductors of electricity, and generally have lower densities than the metals, which means they weigh less for a given volume. Lastly, we have the transition metals, found in the center of the periodic table, here in green. You can think of these as being typical metals, as they have all the metal properties we mentioned before. They also have some extra properties though. One of these is that transition metals can form more than one ion. For example, chromium can form 2+, 3+, and 6+ ions. And these transition metal ions are often coloured. For example, the aqueous forms of these ones would be blue, green, and orange. The most important practical feature of transition metals, though, is that they make very good catalysts, which is an important term to remember. We can describe a catalyst as substances which increase the rate of a chemical reaction without being used up themselves. For example, you'll see later in the course that iron is an important catalyst in the Haber process, which we use to make ammonia, while nickel is used in the hydrogenation of alkenes, which we use to make margarine.